Hello everybody. Today you are going to be learning about 2.2a, rate of change in building stairs. Just a little heads up, with this lesson, it's not intended for you to watch it the whole way straight. I would like you to pause it. If you didn't get something, rewatch it, work with it a partner. When I say pause it, go ahead and pause it and work through the next few problems by yourself. Just follow the audio prompts. So if you do have any questions, you can always email me at dustin.jenkins@sduhsd.net, and I'll get back to you as soon as I can. But let's go ahead and go over this. So if you could, if you need to, pause this and take out 2.2a. And we are going to be talking about rate of change. So before we begin with that, I want you guys to realize we already learned what unit rate is. So they sound a little similar, but I want to make sure we understand the difference between the two of them. So remember, unit rate is when something increases by 1 for your x value. So for instance, a few lessons ago, we looked at the lesson as the hot dog example a few lessons ago, that some guy, Landon, ate 5 hot dogs every 2 minutes. So those were 5 hot dogs, and he ate that every 2 minutes. This is what we would call a rate. But for a unit rate, it needs to increase by 1, so we would divide the numerator and the denominator by 2 to realize that he can eat 2.5 hot dogs per minute. Now, rate of change is a little different than unit rate, okay? So let's go ahead and jump right into it. Unit rate is a constant ratio that compares the measurement in which one of the terms has a value of 1. That's what we just talked about, unit rate. The denominator was a unit 1. It was per minute. So if you think about other per minutes, we know it's 65 miles per 1 hour. If you're ever talking about speed, you never said, hey, I drive 130 miles per 2 hours. We don't talk like that. We usually talk about per 1 minute. Excuse me, per 1 hour. Also, if you get your first job and you make, $12 per hour, similar, if someone asks how much money you make, you'll never say, oh, I make $36 per 3 hours. We just don't say that. Now let's go ahead and look at the difference. Now we're going to be looking at rate of change. Rate of change is the constant ratio comparing change in y values, the dependent variable, with respect to the change in x values, the independent variable. All linear relationships show a constant rate of change. So, what that is meaning is a constant rate of change is in a linear graph. If I were to bring one up really quickly, so here's my x, here's my x down below, and here's my y. If I were to have a linear equation, the linear equation would be straight, and it is going up at a consistent rate. So no matter what my value is, it's either going up and over the same amount each and every time. So let's actually look at a table and see what I'm talking about. We're going to ask, does this have a rate of change? So this is number 1 on your worksheet. So please follow along with me as I solve this. So for a rate of change, it's the ratio, remember, comparing the change in your y value for the change in your x value. So if I were to look at this, week would be time would be my x value, and here, cost would be my y value. Now I'm looking for the change, I'm looking for the difference. So the change from 4 to 2 is just 2, and the change from 6 to 12 is 6. Now let's look here. The change from 4 to 18, that is 14. The change from 12 to 54 is 42. And finally, the change from 18 to 26 is 12. And the change from 54 to 78 is 28. No, I don't think that's right. Ah, there's my mistake. The change from 18 to 26 is 8. And the change from 54 to 74 is 4. So this is the change. This is the change from one value to the next. So rate of change, I'm going to take my change in my y value and divide it over the change in my x value. So looking at this in red, remember, I'm just going to take this 6 and put it over 2, and see that is equivalent to 3. So my rate of change is 3. Now what we're going to do is we're going to do the next value, which was the change in y from 12 to 54. 42 was 42. Excuse me, the change from 12 to 54 is 42. All over the change from 4 to 18, which is 14. And that is also equivalent, if you used your calculator, is 3. And the same idea. I'm looking at the change of 54 to 78 was 24. And the change from 18 to 26 was 8. And that also simplifies to 3. So I want you to take a key notice here. Whenever I take the change in y over the change in x, I get a constant rate of change, which is 3. Okay? Now what else I want us to do is look at the difference when I have some different numbers. So let's go ahead now. Same idea. I'm not actually looking at these numbers, but I'm looking at the change, the difference for my y values and my x values. So let's go and look at this. The change from 0 to 0.5 is just 0.5, and the change from 0 to 18 is 18. From here, from 0.5 to 1.5 is 1, and the change from 18 to 31 is 13. And the change from 0.5 to 2 is 0.5, and the change from 31 to 26 is -5. So what I want to do is look at the change in y and compare it to the change in x. So on my first one, I'm going to have the change, which is 18 over 0.5. I'm looking at these numbers right here, the difference between the two, and that simplifies to 36. Now on number 2, for all these to be equivalent, what I'm going to need to do is to make sure all the ratios are 36. So now I'm going to have the change of 13 over 1, which simplifies to 13. Seeing that my two rate of changes are different, we have come to the conclusion, we can come to the conclusion now that these are not linear relationships. And I can finish this off by having -5 all over 0.5. Excuse me, let's change that. I can have -5 all over 0.5. That simplifies to -10. So as you can see, this rate of change is not equivalent, so therefore it is not linear. So we can further explore the concept of rate of change by examining 3 different staircases on the properly built staircases. All of the stairs have the same measurements. The important measurement on the stairs are what we call the rise. The rise is the vertical measurement, how much we go up and down. And the run is the horizontal measurement. That's how much we go left and right. When we are building a staircase, these measurements are chosen carefully to prevent the stairs from being too steep and to get you where you need to go. One step from 3 different staircases is shown below. So right here I have all staircases. So I want you to notice that I go up 5 and then over 5. This right here is called the rise. This part right here. And the part going over is the run. So let me get a different color. This right here in orange is the run. So I always want you to keep in mind, we're always going to be comparing rise over run for our ratio. Okay, so similar here. Let's go ahead now and jump in. So we kind of just did this one. Alright guys, on number 3 it is asking what the rise and the run is. So just a quick reminder, the rise is how much your graph goes up. Oops. The rise is how much your graph goes up. That's the rise. And how much it goes over, which we'll show you in red, is your run. So by looking at this, you can tell that I went over 5 and that my run was also 5. Now when we look at number 2, I would like you guys to try number 2 and 3 right here. So please go ahead and pause it and continue when you're done making sure we got it right. So just a quick reminder now, this right here is 3, and my run, which is how much I'm going over, is 8. And my final staircase is how much I'm going up and over again. So my rise right here is 4. And my run is how much I go over, which is 6. Now remember, these are all stairs on a staircase. So it's 6 inches high and, 4 inches high and 6 inches over. So now what I want to do is actually build a staircase. I want to build and see how high it is for 5 staircases. As a reminder, the first one was 5 over 5. So let's go ahead and graph that one in orange. So I'd have 0, 0, and then I would go up 5 over 5. That's my first staircase. And then up 5 over 5. So as you can see, I'm building my first steps, and they are 5 inches up and 5 inches over. Oops. And what I would like you guys to do is pause it here and build the rest of the staircase on your own, and then double check your answers with me. Alright guys, here's my first staircase. As you can see, here's my rise over run, and you can see each step goes up 5 over 5. Now the next one I'm going to look at is staircase 2. That went up 3 inches and over 8. So let's go ahead and do that in purple. So I'll go up 3 all the way over 8, up 3 all the way over 8, up 3 all the way over 8, so on and so forth. So when I finish my steps, if I go on up 3 again to 12, over 3 to 32, and up to 15, all the way over to 40. So when I build these stairs now, they should look something like this. And I want you to notice that they're definitely not as steep as my first one. They're a lot easier to climb up, I would say. So your second table should then look something like this. And as you can see, I went up 3 and over 8 on each and every one of those. So the final one we'll go ahead and do in green. That was up 4 over 6. So we're going to do that for 5 steps. So up 4 over 6, up 4 over 6, so on and so forth, until you have all your steps. So go ahead and take a second to finish that as I do that as well. Okay, and last one, up 4 over 6. Over 6 would be 20, 30. Alright, sorry. It's hard for me to talk and write at the same time. So here we go. Here's our steps. And this is right in between the 2 stairs. So I want you to see this was up 4 over 6 as well. So when I talk about the height of the staircase, after 5 steps, which is the height for each of them? So all we do is look at the vertical distance from 0 to the top of the stair. So on my first one, it was actually 25. So that's how much we went up by. My green one, which was my third staircase, it is all the way up to 20. And my most shallow staircase, which is the one in purple, it only went up 15. So out of all my staircases, I want you to see that staircase number 1 was the steepest. Alright guys, from here, go ahead and close this video and open up the second one, which will help you with the next lesson.